Welcome to this webinar on sustainable housing solutions. And SIREUS, who is hosting this webinar, is a collaboration project between SAC USA and 11 Swedish universities focusing on knowledge exchange in innovation, science and entrepreneurship, and increasing talent mobility for students and researchers between Sweden and the US. This webinar will be recorded and you can find it later on YouTube. Before going into the agenda, I would like to tell you a bit about what GTI is about as well. My name is Andrén and I'm the Executive Director of GTI, and GTI is a partnership between the Embassy of Sweden in Washington, DC, Vinnova, the Swedish Innovation Agency, the Swedish Energy Agency, and Business Sweden. And we are set up to be a one-stop shop for collaboration to accelerate the green transition. And we focus on R&D and innovation and trade and investments. And we do that within these 4 thematic areas: electromobility, renewable energy, sustainable industry, and smart green buildings. We set out to accelerate the green transition, and within the built environment, we do that by collaborating around industrialized building methods, new materials, and energy efficiency. Today, we will have experts talking about this. And first we have Ivan Rupnik, and I will soon introduce him. We also had Helena Lidelöw to take part, but due to an unforeseen event, she will not be able to make it. And that gives more time for Ivan and for Gustav Jansson. And in the end, we will have a seminar summary and also potential for Q&A. So if you have any questions during the seminar, please add them in the chat. And so it is my pleasure to introduce Ivan Rupnik, who is a PhD and architectural and urban designer and an associate professor at Northeastern University. Ivan has also co-founded ModX and leading design research and advisory practice focused on industrializing construction, especially in sustainability and affordable housing. So welcome, Ivan. The floor is yours, and I'll stop sharing.
Thank you, Linda. I'm just going to share my screen, and it is probably on the wrong side. Okay, well, really a pleasure to join everyone today. Just wanted to introduce my work as part of a collaborative, ModX. We are a research, education, and advisory group focused on addressing societal challenges through the industrialization of construction with our friends in Sweden and across the world. And so ModX is Ryan Smith, myself, and Tyler Schmetterer. So the brief overview I'm going to give you today is really kind of related to the work we presented this summer at HUD's Innovation Housing Showcase, which is really becoming kind of a premier event for industrialized construction, and also some work that was shared through the New York Times. Real honor to be featured in that newspaper. Francesca Mari, who joined our delegation in Sweden. These are actually from 24, not 23, but she joined us in 23. And you may have had an opportunity to read that piece. So ModX has been fortunate to have studied Sweden from the outside since 2017. And Helena Lidelöw here at Lindbäcks was one of the people that really introduced us to the innovation going on in Sweden that we've been trying to understand and apply to the US context. So we have been working that trip to Sweden was related to some work we were doing for the Modular Building Institute in 2016, 2018, where we're looking at internal barriers to the acceleration of offsite construction, which included capacity, capability, and competency, included a lack of data culture, a lack of industry standards, and a lack of interdisciplinary partnerships. That report came out in 2018. We were happy to see that MBI applied some of those lessons, many of those lessons coming from Sweden. We're also happy to see that research picked up by McKinsey, by AIA, by Fannie Mae, and by Dodge. And that work led to another project with the US Department of Housing and Urban Development, really looking at external barriers to the acceleration of offsite construction. And so that's been published. You have access to that on HUD's website. And really that looked at 6 barriers that we saw still impeding the growth in the US, and also barriers that we saw as mostly resolved in countries like Sweden, And Helena, again, who's not on this call, but it was very active as a member of the Project Technical Committee, the only international member of the Project Technical Committee for this project, helped us understand her perspective on the US and Sweden. So again, Sweden, a big role in this process. Since the completion of the housing research roadmap, we have worked to understand how we can overcome those internal barriers to the acceleration of construction, of offsite construction, and I'll talk about that briefly. And then we also have been developing with the National Institute of Building Science, with HUD, ideas about how to create actions to resolve some of those external barriers. And again, Sweden has been playing a major role. And this is something we're trying to complete as we speak, an action plan, and we'll give you a preview of that. But what we were really impressed while we were working on an article for the Housing Center at Harvard on better techniques for offsite construction, there was a really significant article published by Lars Sten about Sweden's offsite construction sector at a national scale. And really that article proved out something that there has been a hypothesis for a long time, which is that offsite construction used in a particular way can be actually more productive, can improve labor productivity, and can really increase the quality of housing as well at a national scale. So while as researchers, as practitioners, we've all believed that this is possible, it's really impressive to see that Sweden has been able to demonstrate and document those increases in productivity that we've heard about since the McKinsey report and before at a national scale. And really that has not just been a technological success, that has been a success in terms of institutional structure of Sweden, and has been a success in terms of the way that projects are designed, they're manufactured and assembled. And I know Gustav will talk about this more. One of the things we've been studying though through this research is also to see how previous government actions have increased housing supply in the US, in Sweden, and in Japan. So in the 1960s, there was success in government-led actions in Sweden, the Million Homes Program, in Japan, their housing system certification program, and even in the US, Operation Breakthrough, all produced some of the highest housing supply as measured by new housing units per 1,000 inhabitants in the history of all three countries. Offsite construction was a big part of it, where the numbers you can see in the US, as much we think as 35% of offsite of the housing produced at the peak, historic peak of housing supply was produced in a factory. And in Sweden, our scholars, colleagues in Sweden have shown that as much as 50% of the peak production year in Sweden, in the history of Sweden, was produced. In Japan, we're still trying to get the right numbers, but all three countries were really the housing supply winners of the 60s and 70s, and really industrialized construction was a big part of that, as were overcoming, or at least temporarily in the US case, overcoming certain institutional barriers to acceleration. And all three countries experienced one of our first, and unfortunately not our last, global energy crises and recessions. But those three countries had very different survival rates for companies that were developed during these acceleration actions. So in Sweden, just to close, what we've noticed is the development, long-term development of a national innovation system, one that connects government, industry, NGOs, and academias through a quad helix, through strong partnerships, something we learned when we visited in Sweden last year. That has also supported regulatory reform by the agency Modular, which we've also had fortune to work with and will continue to work with, where now regulation balances the need for life safety with human comfort, innovation, and affordability and sustainability. Also, Sweden has been using market demand aggregation through particularly its municipal housing agencies or public housing agencies to also accelerate production further. And what we've really been impressed with is to see that a national innovation system built primarily to increase housing supply has also been able to pivot to carbon goals, which is something I know Linda's also very excited about talking about. So we're really interested in seeing how countries like Sweden and Japan have built an institutional framework that can address current societal challenges, but can also, without major government intervention in the future, at least structural reform, can continue to address new challenges as they come up with a strong housing sector. So we've been looking at how, again, these actions defragment a housing sector and an industry. I'm not going to go through this in detail. This is something we'll be talking about in this report, and how regulatory reform, market demand aggregation together can create a more consolidated housing sector, one that can supply more housing today, but one that can also address future societal challenges in the future without the same major government interventions to restructure the industry. And that really comes down to, again, something Gustav is maybe going to talk about even more, and really an approach to offsite construction, industrialized house building or housing delivery, depending on who you talk to, really a combination of design engineering, manufacturing, and assembly integrated within a company or within a team that supports high-tech housing sectors, which are then supported by national innovation systems of the kind that we've seen in Sweden, we've seen in Japan, and we're hoping to see expand in the US. So we're hoping to see an overall strategy developed for long-term actions based on expedient objectives and potentials for immediate impact. And we find key partnerships that are incredibly important for that, as we've seen in Sweden. So we're recommending, this is the last slide, looking at standardized award criteria for federal projects, for federal awards, and for subsidies. We're looking for housing system certification for, again, based on performance criteria. And we're looking long-term to implementing a performance-based building code and product certification of the kind that are already in effect in Sweden, in much of the rest of the European Union, in Japan, and in most G7 countries. So that's just a quick overview of some of the things that ModX has been up to. And I'm happy to go into this in more detail in discussion, but I'm also happy to pass it on to, I think, Gustav, who's going to go much more into detail into the innovations happening in Sweden. Thank you.
Thank you, Ivan. The next speaker is, as you said, Ivan, it's Gustav. And Gustav is Associate Professor at Luleå University of Technology in Sweden and specialized in industrialized construction, focusing on design for takt-time production. And I'm looking forward to learn more about this, Gustav. The floor is yours.
Thank you, Linda. I will share my screen here. And hopefully you will see me and also the presentation now. So I will focus on takt-time design for takt-time production, and it becomes a little bit technical in that case, but hopefully you follow my presentation. And I am an associate professor, as Linda mentioned, at Luleå University of Technology, and have been made my research with industrialized construction companies since 2007. And why takt-based design is interesting and important is that we have seen from our studies that we have done that when you ramp up a takt-time production, you don't have the time to organize and plan your takt-based design. You already have to set that first. So you do that in parallel with ramping up the takt-time production, because it becomes too fast to handle that. And I will come to some numbers of that later in the presentation. So it's really important, and you can use it also for traditional construction if you like also in that, but our focus has been on prefabricated volumetric modules in that, our studies. Let's see if I can get so. But there are some challenges to create a takt-based design process. So if we see as the traditional process of producing and generate affordable and low cost but nice houses that are not just for the low class use. It could be for the middle class, and also some of this is luxury in that case, but keep the cost down. And also from a sustainable perspective, don't have control over your processes with a timber structure that is environmental friendly. You have the different parts of the process in contract first, and if you don't have everything predefined, you have a design phase there, and after that you have a factory production, transport, assembly, and completion for the entire building. And I will come to this part of how much you have predefined in your platform and how much you have predefined your product. But let's start a little bit about the design process here. If you don't have a fully defined product, which is quite hard to sell on the market, you need to have a design phase. And you start by layout and analyze that. You have a coordination of different disciplines. You have put the sequence of the production of each object, like a volumetric modules and the different elements, and down to component level where you have the detailing. And the detailing is then for the specific station in the factory that you will have some recipes and so on, what they will do. If you like to predefine this with standard operation procedures in design, you need to map the entire process first, not just the design process, but the entire production and the design process also. That is what we have seen also. But also handling the information flow is not so easy. It's not so easy to see it compared like material flow that you have in a factory. The information flow needs support for the progress of the work. So here you need some support tools, systems, and so on that can handle that in the work. But you also not just have the internal challenges, you also have external challenges like project-oriented culture in design. You have rules and regulations that not is the same. What we have seen could vary a lot between the countries, but also down to city levels in different countries also, that you have to follow and you have to handle in some way. And that was a little bit what Ivan was about, how to make this more easy to handle for industrialized construction, especially for this type of buildings. And there is also to handle this project customization, because you need to have this to meet the market and also the site and also the customer use for that with predefined products. And the products do not need to be fully defined, but as much as possible. And that comes to the platform concept later on. And we know that we have long lead times for decision making in design, not just in our internal processes with the suppliers and so on in the organization, but also on the client side that has to take the decisions according to alarm systems and locking systems and ventilation and regulation, and also in their chain, and come back to that. So that takes a little bit to have those decisions for the design. And then you have unmatured clients in buying prefabricated projects, because the timeline is much shorter in the prefabricated projects. But we have more and more mature clients learning to buy the prefabricated projects to have to meet those things. But it's important to have in mind when you try to organize these design phases. But back to my cornerstones for this presentation, and that is the 3 cornerstones of platform approach, to have that in that case. But also be aware of the importance of a good information flow for design. And also the third one is to manage a parallel process for design. So I will go into platform approach first for this. So often you think about the platform of a product platform, and that is central for when you have industrialized house building. And if you start with the picture above here, you see an apartment where you have divided into 2 modules, volumetrical modules, and you have some rooms, and you have windows openings and openings for doors, and larger openings also. These are predefined according to some regulation, not just the position itself, but maybe the specific type of opening and so on, according to that, and how the connection point between the walls and between wall and floor should be, and also the elements itself, how they are. Maybe the level height could be locked in that parameter, but maybe the length is flexible in some millimeters or something for the production or the transport in the case. On the next picture to the right, we have a little bit more in detail. You have some studs that showing up in that one, and you have rules for how they are put out in the walls, so you don't have to do it manually. Also around those openings, you have regulation how that it will be in a rational way, so you don't have to put in this manually in your CAD software or so on. So you have that generated from what you have predefined in that case. And the middle to the right, you have a picture of some boards and also some small nailings if you see some cross dots there. So that there you have nailing or screwing in the factory with automation, either with robots or machines. And these need to be positioned so the machine files could read them. And do that for an entire project with about 200 to 300 modules. You understand, maybe you have at least 5 or 6 walls in that project, and you have a wall and a inner roof also. So it becomes a lot of nails in that to position out. So you have to do the automation there, and you have the rules to how to put them according to the regulation, also from maybe a state regulation, how the code says how you should do that. But also a combination of different disciplines. We see the here some drilling holes in joists and that have to be predefined how it will do it, and in a system perspective, so you understand we don't have so much flexibility, but some is the most of it is locked, but some of this is flexible so you can meet customer demands from a product perspective. The next one is the process predefinitions, and here we see a colorful planning schedule with the colors is representing different disciplines in that case. So this is a design phase with you have some project manager with the light blue, and you have the sales with the pink one, and green is structural engineering, and purchasing is yellow, just to shortly go into that. But it's important to have something to lean on, a predefined process for design, so you can have that and maybe stretch a little bit because we don't have the time for that, but you have something to make. And I even had a small picture that Helena shows in this obeyer room that you go into, and you have all those boards for each project. And in these boards and the planning, you have some of the gates you see in the top there, but also phases and a countdown for weeks before production starts. And that is important to understand, that you have one thing to lean on according to, we are all in this boat to have these deliveries for each activity. And those small cards that we call them in that one has a lot of tasks and so on. So it's formed according to a standardized way of working. Over to another one of predefinition, the technical predefinitions. And technical is a quite vague word, but it describes the product and the sequence of how to produce it, but also some technical regulations. If we start with the stair that we see in the drawing to the right, we have, I can maybe show you with my cursor. The first 2 stair parts is assembled in the factory up to this level. I hope you see my cursor. And here the level is to level 1 in that case. But the small part of the stair is not belonging to that one. It is belonging to the next module level. So it's not assembled in the factory. It is transported up here in the upper part module level 2. And on site assembled, because it has no support when it's transported. And the same thing for the next one. And this is a technical solution that is predefined and standardized in that case. And also from a regulation perspective, according to fire regulation, structural performance, and functional requirements according to the use of the building. So this is another way of predefine also technical solutions. The fourth part of a platform is the combination of a product, process, and technical solution according to a sequence. And then you have something that's called BOM. It's traditional in manufacturing industry, bill of material. You're breaking down your product into pieces. And we do it now. If you look at the left part here, we have from a project levels, and then you have modules, elements, and parts. And this is an engineering BOM, which focus on the product itself. And you have a labeling of each object in that case. And you cannot label everything manually here. You have to be supported by either a CAD software tool or a system that put that labeling on that. So you have an ID for each object, so you can plan that for production. But after that, you also need to put the manufacturing sequence on that. So in a manufacturing BOM, you have that. And that is not the same like this engineering BOM. So maybe you have another sequence of producing. Maybe you gather all the studs in somewhere and cut them in one sequence. And then you have assembling different parts to create the whole product building. And that is also an important part of the platform approach to handle the breakdown of the product. Over to the next cornerstone of the presentation that is important is the information flow. And I was into that a little bit according to the predefinitions, but here you have built in those regulation in BIM software with the automation. We call it design automation in the theory of geometry and information. And in the picture up here, it's what you see is the corner of a window opening, and then you have the wall, and you have boards here. You call it sheeting sometimes, and you have positioned this not just in the corner, because then it becomes cracks in that corner. So you like to push it a little bit over the window. And then you have the nailing here according to regulation. And this is made by the CAD software, by automation. So it generates out those as a suggestion, and then you can fine tune those in the parts that you like it. So this is really important when you do changes, that you can generate up that by automation, so you don't have to modeling it up again and again and again. And the second part is to generate the output from the BIM design process. That you can generate shop drawings like this. You have both sides of the wall, and you also have the studs inside the wall, and you have a BOM list of the all components of the wall in that case. But also machine files that you put to the robots and the machines in the factory. So you don't have to do that manually in programming the machines. That has to be much more rational, and it is made in that one. And the last thing about information flow, that is that you have an overall system that structure the information downstreams of not just machine files and drawings and work instruction, but also for the product itself. So information about the components follow the product through the value chain. So you can have that later on for the customer to take with them with the product. But also upstream information flow according to improvements to improve the entire process of producing these buildings. But over to the last cornerstone, that is to manage parallel processes. If we say we have tact time production, we have a project of 200 modules in that one, and we have a pace in our production about 50 modules per week. It takes about 4 weeks for each project to pass the factory. And then we understand it's hard to match that with the design phase of 20 to 24 weeks. It's hard to match that with 4 weeks. So we need at least 20 to 24 weeks for all the decision that you had to do in design. We understand we have to have about 5 to 6 parallel projects in design then. So that is important to understand, that you don't just play one project in design for one project in factory. You need to have parallel projects ongoing in design, but also match hard and easy projects in design. And hard projects, that is the one that have a lot of complexity according to design making. And also if it's a small project of not so many modules, it will have so less time in production according to the speed there. But the easy project, high repetition, following the platform per definition well, and has a lot of many modules in that case, so you have the time to do the design. But the match has to follow the entire flow of production in the factory. And to the other side of it is progress control. So you understand in which status do we have our BIM model on layout, system and elements and component level. So we are secured, we have locked those parameters for the different parts. And also this secure DFMA design for manufacturing, for factory and site. So it's buildable both in site and in the factory. And also the output from design of critical information for purchase and planning. If you like have specific, say stairs or windows, so the sub-supplier or the supplier have the time to produce it so it comes back before assembling. So these were the three cornerstones that I like to present in that case. So, and I like to, when I have the time now, just shortly do a small presentation according to our publication about this. So this is from an architect perspective, more from a concept of the product, a number of publications we have done in our division, but also from an engineering design perspective, how you manage the design work, and also for the production planning according to using different technology, but also from a more management perspective, and also supply chain and logistics in the planning, and business model for productivity. So that was my presentation. Thank you.
Thank you very much, Gustav. And I hope that you will also stay for the discussion now that we have extra time for the discussion as such. You talked about differences between Sweden and US and knowledge sharing, but I was also thinking, can you elaborate on the performance-based codes? Is that a difference between the countries as well?
Yeah, so I think what Gustav used the term functional codes, which is a European term for performance codes. So again, there's some translation that needs to be done, which is great. So most countries until the 50s or 60s used prescriptive building codes, which essentially defined the recipe for building, whereas in other industries, automotive, so Volvo or Ford, in aerospace, Boeing or Airbus, those industries moved to a performance science-based, functional-based criteria for manufacturing industries since the last 100 years. So in Sweden, you moved to a performance-based code in the 80s, but actually you've used, in early 90s, but you've used performance criteria for building products since the 60s. That has had a huge impact on allowing the knowledge that Gustav just shared to become industry-wide, we think, from the outside, to really have a manufacturing approach to housing. In the US, there's been goals since the 60s to introduce a manufacturing-friendly, science-based performance code, but there's been difficulties to its application. And we see that directly related to, while there are innovative companies in the US applying a thinking that Gustav just showed industry-wide, it's not just that companies aren't interested in this more manufacturing approach. It really, in some ways, comes into conflict with our regulatory environment, with our contracts, with our insurance, with our financing, all these things.
So, follow-up question on that.
Sorry.
Then the US is a huge country. You have many states in the country. So I assume there is differences between the states as well.
And so so you're right, but the European Union is an even more complicated mix of 27 countries. That's always my answer to that question. So while Sweden, Norway, in Norway were some of the first adopters of performance codes, Norway before Sweden, although Sweden's market share is now better in offsite. There are countries like Germany, for example, which has 19 different federal regions, all of which have different building codes. And it's interesting, their harmonization with Eurocode since 2010, you can also follow in Germany, which is a more complex political unit than Sweden, the same issues that we are having in the US that you would have within a state. So yes, the US is a more complicated political entity than Sweden. It is not necessarily a more complicated political entity than the European Union. And the European Union, thanks to the positive results that Sweden and Norway have had and other countries have had, and that the European Union has had since 2010, has found ways to encourage different countries with different building cultures, but common carbon goals to adopt a performance-based approach to building codes. And it wasn't fast. It's taken, it took Sweden years. It's taken the European Union 50 years. The goal of a performance code was set in the 70s. And it took until 2010 to really become widespread. But again, the results have been really consistent. Same in Japan, same in New Zealand. We really see that this shift to performance code, which is a difficult process, creates the necessary environment so that the kind of sophistication that Gustav just presented on becomes industry-wide. Isn't just the area of a few innovators while the rest of the industry applies a more conventional approach.
I also would like to follow up trying to cover what I think Helena would have addressed when it comes to sustainability, or more specifically, the emissions from the buildings. Do you have any reflections on that? What is the pros with offsite construction compared to other ways of building houses?
Well, so again, the performance environment, the performance-based environment, it makes it very easy to adopt not just existing factors like structural load or human comfort in terms of acoustics. It's proven that performance codes in Europe and in Japan, it's much easier to append new carbon targets without changing the industry, as opposed to in a prescriptive environment where now you are giving solutions as opposed to creating an environment for industry to innovate on. So actually, Helena has tried to explain this to us, and we tried to explain it to the New York Times, thanks to Helena, which is how carbon targets, both for energy building performance, but also for the embodied carbon of construction processes, have been much easier to apply European Union-wide in countries that have very different carbon targets, because the European Union has allowed different countries to map out their goals in different ways using a common format. So again, so it puts on-site, off-site, concrete, wood, steel on equal footing and says you can achieve these performance criteria around carbon how you choose. You can innovate how you choose, but those are common. And so again, that's what we called even that national innovation system, having a common platform, having clear societal goals, and then creating an environment like in Sweden, where multiple companies have been able to innovate their own route to an equal societal goal. That's what we've really been impressed with Sweden, but what we're seeing EU-wide in countries that are not as, let's say, far on the offsite industrialized path.
I think also you mentioned that the productivity gains and the labor gains were there, but and looking at your presentation, Gustav, as well, I think what I see is also an optimization of material use, so that in the factory, is it so that you would have better control and therefore less waste, less energy use, or do we see any such benefits when it comes to like the climate mitigation of the buildings?
Yeah, when you do it in the factory, you have pre-cutted objects. So you do that by automation according to, like I showed a little bit of the design automation. And then you can optimize your material flow also from a logistic perspective. So you don't have to, and you can use that by have that in the same factory environment, where you can maybe, if you like to have it, your control of your energy sources also, if you like, you have sustainable energy sources like solar panels and so on, you have them that distribute that to the different production units inside that. And you can also, when you buy things, often you do it pre-cutted from the suppliers in that case, so you don't have so much waste there in that case, comparing to on a site where you maybe do it traditionally for the specific, and you have those parts that comes off that, and you have to also work with that to get them away from with diesel engines to get them from site again. First, both ways. So.
Thank you. I see that we have a question also in the chat, and that is, what is realistic timescale for adoption of such approaches in the US? I think it's for you,
so
even. Yeah.
that's great. That's a great question. So, the European Union, as a very complicated entity, set these goals in the late 70s. But Sweden, for example, being an innovative future member before Sweden became a member of the European community, decided to have a competitive advantage by adopting these codes before they were required. So Sweden spent Modular spent about 5 or 6 years since its founding, the agency that really developed performance code, 5 or 6 years. They were assisted by some, goals at the European Union. So 5 or 6 years is a number that I think is realistic. Japan took about 2 years, but had a lot of experience. So we are trying to ascertain that. We've seen horizons, for let's say 2 presidential mandates in the U.S. Would be enough, we think, based on the evidence we have from other countries that have chosen to do it. And again, like in the European Union, Sweden chose to push this before anticipating a long-term goal. European Union said that this would be in the future, this would be a goal. Sweden said, we want to be competitive as a domestic economy, but also in terms of exports, and made the decision to do it earlier. I would imagine a similar way that healthcare has changed in the US, where Massachusetts adopted some innovative healthcare approaches and then they became national. I would imagine a similar timeline. So, it could be 4 years, it could be 10 years. The goal is to have the goal and to understand the benefits of it. And that's what we're trying to do. And that's why these dialogues are incredibly important, because we see every other country that the US sees as a peer going in this direction. We don't see an alternative.
So I know also the US has a large housing deficit, and there is a focus on reducing the cost from the buildings. How about demand for sustainable or green or climate neutral buildings? How do you see that?
Well, I think we can't separate those two, even from the perspective of economics. We know that those are connected. But again, we're trying to understand this as researchers too, that in Sweden, for example, really the drive during the Million Homes program was supply. It wasn't sustainability. It was, but during a period of a need for high supply, a mature industry grew out, and that industry could then, through regulatory reform, start to also provide additional benefits economically without major government intervention. That's really what we're trying to understand, is how much structural change is enough so that we can start to address these societal challenges without major societal structural reform in the future. So the shift to performance code in Sweden happened on the back of an industry that was already quite mature, and that now performance code could adopt that. In the US, I think one of the things we're struggling with is particularly climate mitigation. So we're seeing, beyond even carbon, creating affordable buildings that can withstand our current climate changes in terms of hurricanes, in terms of earthquakes. And so again, we're looking at Japan as well. Once we understand that these new performance criteria are societal goals that we have no choice but to address, it becomes a lot easier to say, okay, this is the goal we're achieving. How do we make that economical? How do we make that addressable? And how do we make that affordable, knowing that we don't have a choice but to make buildings more resilient? So this is the process that we're in, is balancing all these questions. We still think a performance-based environment, a platform-based approach are the only way we can do it economically, but it requires structural reform.
Thank you. And Gustav, looking at your presentation, when you show the BIM and the data of the building, it sparks an interest from my side in the reuse of buildings. As we are talking about a deficit now, and maybe there is a need for buildings in a certain area, but depending on how urban cities develop and so on, the need for buildings can move to another area potentially. And then would it be easier with the modular construction to reuse buildings as they were shipped there as units? Is that an upper side as well?
Yes, because you have the possibility to do that, and that has been tested in a number of projects to reuse volumetrical modules to deassemble and assemble for circularity of the entire building, but also for some projects just to use some part of the building to use it from a circular perspective, which is quite hard with other materials in that case. And I know there are some projects also they are developing there just for the specific that you transform for the functionality of the building just from different that you use it first for one purposes for a function of that to another function for the housing perspective. That is interesting to follow, that you can use the building for different purposes in that case, but don't have to tear it down and build it up again. So it's from a circular perspective, you can think of different directions in this.
So then existing buildings are banks of materials or banks of modules that can be used in different places. And then the data sheets following it, it's also giving the ingredients, so you know what you have in the walls and in the material that has been used.
Yeah.
That was not a question. It was my off-site construction is a good way forward for sustainable housing and to address the affordability as well. But I have myself run out of questions and I don't see any more in the chat. But do you have anything else, Gustav and Ivan, that you would like to stress in this seminar?
There's one more question about workforce employment, which I think is a big issue in the US. So maybe I would ask Gustav to talk about the impact of workforce employment in Sweden. How has the shift to platform thinking changed, particularly the mix of who works in this space and how, as Sweden's become more innovative and more, who works in construction that may not have worked in construction? What's changed?
Yeah, from a production perspective in factories, there is a combination of the knowledge that knows how to build buildings. That is important. So you don't put in just production personnel there, but it is good that you don't have carpenters that is in the production line. Of course, they are good to be there, but depending on the individuals, if they like to do it more from a production perspective or more from a carpenter's perspective. But on a design perspective, if you are a designer with platform thinking and so on, we have seen a lot of developing things in Sweden that have focusing on more from the rationality according to minimize the cost and also to generate those sustainable values in those. So you have predefined them. So there are some projects now that focus on circularity for in the platform thinking. So you not just put in the parameters of how you produce it efficiently or in that case, but also when you do those predefinitions in the product and the process, you think you have already set for circularity loops, the different loops of circularity, if you say so, for reuse or reassemble and so on. When you generate your products as building, so because that is used not just in this design for prefab, but also for design for traditional construction projects.
Thank you. And anything else you would like to bring up, Gustav, from your side?
Yes, it is about the ramp up. It is you have to think for the entire process, so you don't just focus on the factory. You have the design first. I was focused on that in my presentation. That has to manage parallel process I mentioned, but also after when you have the assembled on site. Because if you ramp up with high speed, you need to meet that for the assembly team to take care of a high speed of modules that come to site, both with the crane, but also with the last work of that. So you have the entire chain has attack-based thinking. So you don't just focus on the factory, but the factory you have invested a lot of money, of course. So then it becomes focus on that. But it's so important to have a learning organization, especially for the site, to assemble those things that are coming out. So you don't just leave them alone, if you say so, to fix what's the rest.
Thank you so much. I would like to just show also give a bit of heads up that SIREUS, let's see, now I need to move forward. This have we already seen. SIREUS is also running more research forums, and if you are interested to follow more of these, then you can find information on the SIREUS.org homepage. And I also wanted to give a shout out for an upcoming event here in DC, Green Transition Summit. It's hosted by GTI in collaboration with the Embassy of Sweden in Washington, DC, and World Resources Institute. And here we will talk about city transformation and built environment. And the pictures here are from last year. But it's upcoming this year as well. And if you're interested, please reach out to GTI. And if you would like to follow us, you can follow us on LinkedIn. And here is a QR code for that. And with this is the last slide that I intended to present. And in this one, you see a fantastic building, Sara Kulturhus, that is built in wood and with modular principles as well. So with this, I would like to thank the speakers and SIREUS for arranging this seminar. Thank you so much. And thanks to the attendees as well.